Hi guys, welcome to today's lesson. So today we're going to be focusing on expanding terms, right? This is under algebraic expressions. But before we do that, I just want you to think about something. This will be the leading question. It will be like the big idea of this particular lesson that we are having today. So let's look at what exactly that is. Now, have you ever thought about why is the term a to the exponent of 2 called a squared, right? I'm calling it a to the exponent of 2 because under exponents, that's what we call it. But normally people then say this is a squared. Why is that the case? Just think about that and you will see at a later stage that I will show you why that is the case. Now, the main operation that we're going to be dealing with is multiplication. And we're going to have what we call factors under multiplication and the two properties of multiplication, which is your associative and your distributive. And then we'll look at the 3 types of expanding terms that have to do with a monomial, a binomial, and a trinomial. Now, as simple as this question is, what is multiplication? I promise you, if you do not understand what exactly is multiplication, then everything that you're going to do when you are expanding will not make sense. So multiplication will be a short way of adding the same number to itself a certain number of times. So for example, if I say to you 3 multiplied by 4, what that means is I am adding 4 to itself 3 times. Or I am adding 3 to itself 4 times. If you want to take it in that direction, it will still give you the same answer. So 3 plus 3 is 6, plus 3 is 9, plus 3 will be 12. Similarly with, 4 plus 4 is 8, plus another 4 will give me 12, right? Also, if we use it under algebra and I say 4a, I know that most of us look at 4 as just a number and a as just a letter. But what really this means is it's a plus another a plus another a plus another a. So it means we are adding a to itself 4 times. That's what 4a means, right? Now also, 2 numbers multiplied together, we call them factors because we really do need to get our language clear in what we are talking about. And then the answer that we get when we are multiplying is called the product. We have 2 properties as I showed you with our map. That the first property is the associative property. This means that it does not really matter the order of the numbers that you are multiplying. Right? If it's 3 times 4, it's the same as 4 times 3. It doesn't really matter your order of multiplying as long as there's a multiplication between those terms. Not division, not subtraction, no, just multiplication. Now, let me just show you. 4 multiplied by 3 we know is 12. 3 multiplied by 4 is also 12. So that's what I really mean. Similarly with a multiplied by b, remember we write it as ab, which is equals to b multiplied by a is ba. But you know that mathematically, if I'm writing a term that has variables, we normally follow alphabetical order, right? Hence, this is supposed to be ab, which is the same as the first side, or rather the left-hand side of this. Now, with the distributive property, this has to do with if I am taking a number outside the bracket and I'm multiplying it throughout all the terms that are inside the bracket. Hence, it's going to be the 4 multiplied by the 2 and then the 4 multiplied by the 1. But before we do that, let's look at how you would do this if maybe you were to use BODMAS, right? Because remember, everything that has to do with numbers is governed by BODMAS. I would say this is 4, and then BODMAS says you must work out what is inside the bracket. 2 plus 1, you know, is 3. Therefore, 4 multiplied by 3 will then give me 12. But if I want to use I want to get the same answer, but now using the distributive property, it means I will say the 4 multiplied by 2, which will give me the first part there, and then 4 multiplied by 1, which will give me the second part there. 4 multiplied by 2, you know, is 8, plus 4 multiplied by 1 is 4, which will then give me 12. So at the end of the day, this is the same as the associative property that we spoke about, where you are just multiplying the terms. Now, we also have what we call a monomial, right? A monomial will be an algebraic expression of one term. Mono means one. Then binomial will then be an algebraic expression. Now, this is important. It's either a sum or a difference of two terms, not when you are multiplying or dividing terms. That has nothing to do with it being a binomial. So a binomial will be like a plus b or a minus b. So the two operations that govern a binomial will be plus and minus, not multiply, not division. Now, the properties of multiplication, remember the distributive property, especially when you talk about algebra, says that when I have a term outside the bracket, I need to multiply it, I need to distribute it using multiplication to the terms inside the bracket. Hence, it's going to be the a multiplied by the b, which gives me ab. It's the a multiplied by the c, which gives me ac. Everything else stays the same. So the sign in the middle here, which is the plus, does not then change and become something else. Now the variable a will then be what we say we are distributing using multiplication to each and every term inside the bracket. Now let's look at a typical example of what exactly this means. If I have a monomial, remember 3x I said is a monomial, and then x plus 3 is a binomial. If I'm multiplying the two terms, then I will multiply the 3x with the x first, and then the 3x with the 3 there. So this will give me 3x squared plus 3x multiplied by the 3 will then give me 9x. And then there is really nothing that I can do. Remember, when you started doing maths long time ago, we spoke about like terms and unlike terms. These are unlike terms, so I will just leave them the way they are. Now also, if now we are talking about a binomial multiplied by another binomial now, what this is, firstly, you will take the first term in the first binomial and distribute it to all the terms in the second binomial. Take the second term, distribute it into the bracket of the other binomial. So that becomes a open bracket c plus d plus b open bracket c plus d. Now let me show you, if the sign between the two terms of the first binomial was minus, you would still maintain that, right? So if I had a minus b into c plus d, I would still maintain this minus. So this will be a into c plus d, then minus the b open bracket c plus d, right? So I don't change the sign. You maintain the originality of that sign. And if you do multiply this using what we've spoken about, it will be AC, this will be AD, that will be BC, and that will be BD. Then from there you can see that you really cannot do anything there because those are not like terms, right? They are unlike terms. But so far, guys, what we've looked at is multiplication is quite a very big thing to look at. As simple as the question, what is multiplication? You might think it's a very simple question. No, I know what multiplication is. To be honest with you, it involves a lot of things. As we saw, it's the associative property and the distributive property, and then the types of terms that we have, a monomial, binomial. Later we'll look at what we call a trinomial and then try to see what it is all about. But for now, because we've really been doing a lot, I want you to take a quick break and we'll be back with some more. Hi guys, welcome back. So right now we're going to look at something else, right? Remember I said our leading question was, why is a to the exponent of 2 called a squared? That's what we're going to try and look at in this particular segment of the show. Now, remember the question that I started with, right? A to the exponent of 2, why is it called a squared? Now we're going to use what we call a quadrilateral to try and show you what exactly this is all about. So what I have here is a square, right? You know a square will be a quad with 4 equal sides, and then the adjacent sides are perpendicular to each other. Hence, I showed you the 90-degree angles there, right? So what I have with this is, you know that the area of a square is given by a multiplied by a. Or rather, because this falls under rectangles, we can say it's length multiplied by breadth. But because the length and the breadth are all equal, we just say length multiplied by length. Hence, it becomes a multiplied by a, which then gives me a to the exponent of 2, right? This is a big idea. This is where the a squared, why? Because of the concept of a square, that we are taking a and we are squaring it. That's what we are trying to do here as the big idea. But now, what happens now if the area has a side length of a plus b? So it's no longer now just a, right? As I had with this one. If I add a portion to this particular square of mine and then I make it a plus b each side, how will I then find the area and what will that give me? So the shape will look something like this, right? So on the side here I will add my length, which is the b there, and you know this is still a here, it does not change anything, and that is the b there. This will be b because of this one here. So it means I have a rectangle here which has a and b, and I have a new square there by the corner which is a square b by b. Now, to try and talk about this, if I want you to find the area of this, right, I'm firstly going to label them. I will label this 1 so that you see where we are going, right? And then I will label this 2. I will label this one here 3. I can't really write on it because then you won't see what I'm going to write. And then here I will label it 4. Now, if I want the area of this whole thing, it means that it needs to be a plus b multiplied by a plus b, right? But what does that give us? Remember that shape 1 is a square, shape 2 is a rectangle, shape 3 is a square, and shape 4 will be a rectangle. So shape 1, for area 1, it will be equals to a squared. You remember that from the previous example we did. And area 2 will be equals to a multiplied by b. And for area 3, which is another square, will be equals to now b squared. And for area 4, it is a rectangle, so it will be b multiplied by a, right? So what does this tell us? This tells us that if we want to find the area of the whole shape, we must add area 1, 2, 3, and 4. That will give me a squared plus ab plus b squared plus ba. But you remember you need to group the like terms. So the ab and the ba are like terms. If you add them, they will give you 2ab in the middle, and then I'll have b squared there, and then I'll have a squared here. Now, the beauty of what I've just done is what we call trying to square a binomial, right? To square a binomial, what that simply means, you are multiplying that binomial by itself. Remember, I said when we started, it's a plus b multiplied by a plus b. So that means it's a plus b all squared. And to multiply that, remember, you still use the distributive law. the A is multiplied by that A, and the A is multiplied by the B, which gives me A squared and AB. And then the B is multiplied by that A, and the B is multiplied by the B there, which gives me BA and B squared. So if you add your like terms in the middle, it then gives me 2AB. This is really the beauty of mathematics, guys. This is what shows you where the A plus B all squared comes from, and what does it give you if you were to square a binomial. Because remember, we've been trying to square a monomial all the time, but if I square a binomial, what does then that become? But now, this is just a long way of doing this, right? To have to multiply each term with every term in the other bracket. So we then find a way that is short, because remember, we are very smart people, mathematicians. I mean, we know what we are doing. So we use what we call FOIL, right? And the FOIL will be first, which is the F, and then the O will be the outers, the I will be the inners, and the L will be the last. Now, in practicality, this is what I mean. The first will be the first terms in both the brackets, and then it will be the O, which is the outers. So it is the outer terms of the brackets, this one and that one. And then the inners will be the inner terms of each bracket. And then it will be the last, meaning the last term in each bracket multiplied together. So if I multiply the first, it will give me AC. I multiply the outers, it will give me plus AD. I multiply the inners, it will give me plus BC. I multiply the last, it will give me plus BD, right? This is the same as if you were to use the distributive property as we've been trying to look at it. So if I use the distributive property, I would write A open bracket C plus D, right? And then this must be plus B open bracket C plus D, right? So this gives you roughly the very same answer. Not even roughly, it will give you exactly the same answer as what I have. Because the A multiplied by C will give me AC. The A multiplied by D will give me AD. The B multiplied by C will be BC. And the B multiplied by D will then be BD. And that's what this is all about. So this will be the easier method of how to try and multiply two binomials. Now let's look at a typical example of what this means. If I have 3y minus 1 multiplied by 2y plus 4, two ways. You can use FOIL, you will get the same answer. You can use the distributive property, it will give you the same answer as what you did when you use FOIL. So I'm going to use both of them just so that you can see what I'm talking about. So the first method will be me using FOIL, right? If I use FOIL, it will be the first, which is 3y times 2y, that gives me 6y squared. And then it will be the outers, which are those ones there. It will give me plus 12y. And then it will be the inners, which are these ones here. It will give me minus 2y. And then it will be the last, which is the minus 1 and the 4, which will give me minus 4. And if you simplify this, it will then give me 6y squared. The 12y minus the 2y will give me plus 10y, then minus 4, and that will then be my answer. That's the first method. If we use the very first thing that we did in this lesson, which is the distributive property, I would then say 3y open bracket, 2y plus 4, and then minus, remember I said we maintain each sign that we have, 2y plus the 4, right? And then you use your multiplication or your distributive property, which then it becomes 6y squared plus the 12y minus 2y minus 4. And then 6y squared will remain as 6y squared. There's really nothing I can do to it. Plus 10y minus 4. And that's what you then need to make sure that you do understand on how to actually do. So you can see that, excuse me, both my answers are the same thing, irrespective of the method that you use. But now I know that you guys will take the method that works best for you. That's very correct. And that's very okay, right? As long as you do understand what you are trying to do. And what you are trying to do will be to multiply each and every term that is in one bracket with every other term that is in the other bracket, I mean. And that's the goal here. How you do that, it's really up to you, but only if you are not violating any mathematical laws, because I know you guys like concocting things. But from now on, I know you're going to do the right thing. So just make sure that when you're multiplying, you are multiplying correctly, either using FOIL or using the distributive property as we just did now. Now, one more example that I just want us to quickly look at that has to do with this will then be if I multiply two terms, right, such that the middle term vanishes, meaning I no longer have the middle term. What does that mean? So this is something that I'm just going to introduce now, because at a later stage you're going to talk about it. So if, for example, I give you 2y minus 1 in this bracket, and here I give you 2y plus 1, right? How will I then work that out? So let me just erase this, because I know that you've already written it down, so that I can show you this one here. If I work out this one, I'm just going to use FOIL, right? But you can use either or. 2y multiplied by 2y will give me 4y squared, and the 2y multiplied by the 1 there will be plus 2y, and then minus 1 multiplied by the 2y will give me minus 2y, and then minus 1 multiplied by 1, it will then be minus 1, and that's what I will then have there. Remember, you work out your like terms after doing that, so it will be 4y squared. The 2y minus 2y is going to be 0, so this will all be minus 1, and that will be the final answer that we have. And there isn't really much that you can do from here. So at times when you're multiplying two binomials, you're gonna get three terms. We know we're gonna call this something at a later stage. Or you can multiply two binomials. Instead of getting three terms, you then get two terms that we have, and you can see they are subtracting each other. But also, we're going to give this a name at a later stage. That's it from me, guys. I hope you've been having a blast, and you are still going to have some more blast after the ad break. Let's just quickly take an ad break just to freshen up our brains and come back to do some more work. Stay tuned. Hi guys, welcome back from the ad break. You are still looking at expanding terms, right? Expanding terms under algebraic expressions. Right now, remember, we've looked at binomials, monomials, and all of that. We're going to look at a bit of an extra thing, which is your trinomial and a binomial, and see how exactly do we then do that. So remember that a trinomial will be what you call an algebraic expression that consists of three terms, right? So this has three terms. Why? Because of the tri there. You know that a prefix always makes a very huge difference. Then the product of expanding two binomials is called a trinomial. So if I multiply two binomials, which I'm just going to show you next year, we get what we call the trinomial. And then those two binomials that we are multiplying, we then call them factors of the trinomial. So, all right, so let's look at an example of exactly what do I mean when I say multiplying two binomials gives us a trinomial. Remember when we spoke about expanding binomials, we're just going to use the very same example. So if I multiply 3y and 2y, I will then get 6y squared. 3y by 4 gives me 12y. Minus 1 by 2y gives me minus 2y. And then minus 1 by 4 gives me minus 4. And this will then end up being 6y squared plus 10y minus 4. So this answer that I have here at the end is what we then call the trinomial. This is what we call the trinomial, right? And remember what I said. I said when we're multiplying two binomials, we get a trinomial. But what do we call those binomials? These two binomials, we then call them factors. Right, so remember that a factor will be a number that you multiply with another number to get a certain number. So for example, if I say 10, what are the factors? You know it will be 5 and 2. How do you know that? Because you use multiplication in between. That's why there is a multiplication between these two binomials. So that's the big idea here, that if I have two binomials that I'm multiplying, they will forever give me a trinomial. Most of the time. At times you saw with the other one, it does not give you a binomial, a trinomial rather. Now expanding a binomial by a trinomial now, so to multiply two terms by three terms, you use the distributive law. This one does not have some hidden things to it. Remember before we said binomial by binomial, we can use what we call FOIL. Here, it's solely going to be the distributive law. What does that mean? It means this is going to be x distributed into the a plus b plus c, right? Then plus the y distributed into a plus b plus c. And the answer that you're going to get from there, x by a is ax, x by b is bx, and x by c becomes cx. And then y by a is ay, and then y by b becomes by. Lastly, y by c becomes cy. So that's what you will then get. But you can really see here that this will not even give you any like terms, right? Because we're just doing it in general terms. So all of these ones have x, these ones have y. They don't have anything in common. But let's look at a specific example now of how we then apply this concept I'm talking about. So firstly, remember, each term will be distributed into the trinomial. X squared, I'm already thinking about the answer that I'm going to get, which is x cubed. So this is x squared minus xy plus y squared. Close my bracket, plus y into x squared minus xy plus y squared. Now guys, I know that with these kinds of questions, someone then might ask, why do I then not take the terms in the trinomial and multiply them by the terms in the binomial? That's still okay if you want to do that. It's just that you're going to then write a lot of things down, right? It's still perfectly fine. It's an either-or situation. You can start with the trinomial, take each term, and multiply it by every term in the binomial, or you can do it the way I'm doing it. So to answer the question, why not use the trinomial as the one we are distributing? You can. It depends on how you want to do it, right? So this will therefore be equal to the x multiplied by x squared will give me x cubed. X multiplied by xy will be x squared y. And then x multiplied by y squared will be xy squared. Then y by x squared, that gives me x squared y. Y by the xy, there will be minus xy squared. Then lastly, y by y squared gives me y cubed, right? And then from there you group your like terms. So I'm just going to use a different color for this. This is a like term with that one there, the x squared y. And this one here is a like term with the y, with the xy squared. If you work it out, the answer will be x cubed. So minus x squared plus y plus x squared y gives me 0. Xy squared minus xy squared also gives me 0. So at the end, my final answer will be y cubed. So it will be x cubed plus y cubed. So what this means, this is then the sum of two cubes, right? Remember, at times you get a difference of 2 squares. But this one will be then a sum of 2 cubes, because the first term is a cube and the second term is a cube, and they are being added together. But at a later stage with other lessons, we'll look at what exactly are cubes and try to expand that greater and see exactly how do we then solve this if you wanted to reverse things and all of that. But for now, let you take a quick ad break, and I'll be back with some questions to then bring all of this into perspective so that you can see each question under each concept that we've done and see how the answer will then be once we use all the concepts that we've used so far. Stay tuned. Hi guys, welcome back to the show. So we are now in our last segment of the show. We are going to look at a range of examples that are particularly addressing everything that we've done thus far. And then we'll close it off with a quick summary of everything that you need to look out for when you're working out with expanding terms, right? But for now, let's just jump right into it. So the question always will either be expand and simplify the following, or they will just leave it as expand the following terms. Sometimes when they're trying to be then extra, they can say evaluate the following, which really means one and the same thing. So you just need to look out for those words, but they really just mean the same thing. Now, to expand this means we need to multiply that by everything that is inside the bracket. Remember, the monomial here is a negative. So negative 5a times 2 will be negative 10a. Negative 5a times negative 3a will then be plus 3 times 5 will be 15. A times a will be a squared, right? Now, as I'm doing this here, something is coming to mind. At times, when we are multiplying two terms, right, and we find that the terms have a coefficient and a variable, sometimes we kind of get lost on how to then go about doing that. Please make sure that if one term has a coefficient, the other term has a coefficient as well. You can start by first multiplying the two coefficients and then multiply the variables, right? So in this example, I have minus 5a minus 3a. My two coefficients is minus 5 and minus 3. You times them, you get the answer. You times the a and the a, you write it next to the answer you got initially. And that becomes your answer. So that's just one of the ways that I can say, if you are not really sure how to multiply them, make sure that you do follow that route. Now, the second example has to do with squaring a binomial. Remember, when we talk about squaring something, is multiplying the same binomial by itself. So this becomes 2x minus 3 multiplied by 2x minus 3. And this will then be equals to the 2x multiplied by the 2x. This will be 4x squared. The 2x multiplied by negative 3 will be negative 6x. And then the negative 3 by 2x will be negative 6x as well. then lastly it will be plus 9. And this will then be, because you need to work out the like terms that are in the middle, it becomes 4x squared minus 12x plus 9. You don't really then need to simplify anything further here, because some people will want to take out a common factor of these two things. Please don't even go there. When you are here, you are done. There's really nothing that you can do here. Just to also remind you of what we've looked at so far. Remember we said when we multiply a binomial with another binomial, our answer is going to be a trinomial. At times you'll find that the trinomial does not really have the middle term, like this example. So in this example, multiply the 3y and the 3y, so it's 3 and 3, which gives me 9, y and y gives me y squared, and then the 3y by the 2 gives me 6y, the negative 2 and the 3y gives me negative 6y, and then lastly negative 4. And this will then be equals to 9y squared. So you can see the middle term becomes 0. So this becomes minus 4. Now, generally we said that if I multiply a binomial and a binomial, we then get a trinomial. But at times there's special conditions to this thing. And these special conditions is then what we then call the difference of two squares. Remember the previous example we looked at gave us a cube plus a cube. And I said there's a time where it's a square minus a square. What that means is if you are multiplying one bracket that has two factors that are the same as the other bracket, but with opposite signs, you will always get a binomial at the end and not a trinomial like we said in general terms. So that's one thing that you also need to please pay close attention to. Now another example, which is part of the examples we've looked at so far, if I multiply the 3y and the 2y, I will then get 6y squared. Multiply the 3y and that 4, it gives me the 12y, minus 1 and the 2 gives me negative 2y, minus 1 and the 4 gives me negative 4. And this will then be equals to 6y squared plus 10y minus 4. Right, so this is the condition where after multiplying the two binomials, you actually get a trinomial. So far I've shown you three examples of multiplying two binomials. It's this one where I get a trinomial for sure, and it's this one where I get a binomial as my final answer, and it's this one where you then get a trinomial as well. Now, with the first two examples, I want you to look at something. I said if you multiply in one bracket that has the same factors as the other bracket, but with different signs, you get a binomial. But if you look at this one, it has a minus and it has a minus. What does that tell you? It will not be something squared minus something squared. It won't be. Why? Because of these two minuses that I have. If it was something else, maybe a plus and a minus, or a minus and a plus, irrespective of the order, then you will get this something squared of mine minus the something squared, which we then call the difference of two squares. And that's important when we get to the concept of like factorization and all, but we'll look at that at a later stage. Now remember, the other example is multiplying a binomial with a trinomial. If you want to do that, the first thing that I can always advise you to do is to rewrite it in terms of the distributive property. Because I know you can just multiply it from the brackets and get your answers, but it's always just easier and nicer for you to do it and rewrite it in terms of the distributive property. So this becomes 3y into 2y squared plus 3y plus 4, and then minus the 1 into 2y squared plus 3y plus 4. So if you then apply your distributive law here, you will then find this to be 6y cubed and then plus 9y squared plus the 12y, right? That's the first bracket. The second bracket will give me 2y squared minus 3y minus 4. Now, it's really important for you to note that this minus 1, although in maths we hardly write a 1, because of the negative, you must please indicate it as -1 and not just a negative, so that when you are multiplying, you then know and you are clear as to what exactly are you multiplying. Now, let's just group our like terms, the 9y squared and the negative 2y squared, the 12y and the minus 3y. So this will give me 6y cubed, 9y squared minus 2y squared will be plus 7y squared. The 12y minus 3y will give me plus 9y, and then lastly minus 4. And that will be the final answer there. Now, the other things as well is, remember as we initially spoke about this, some people might prefer using the bigger bracket to multiply with the smaller bracket. It's really up to you. It will still give you the same answer. It will just become a very long calculation that you're going to do there. Now, what then if I have 3 binomials multiplied by one another? What this is going to then need you to do is you then follow BODMAS, right? If inside the bracket you can simplify, good. You must go outside the bracket and then remove the brackets. But you can't remove all brackets at the same time. So you must choose which ones you're going to start with and then continue like that. So I'm just going to start with the first 2 brackets. The last one, I'm going to rewrite it as is. So this will give me 6p squared plus 8p plus 3p plus 4 in brackets, and then this is multiplied by 3p minus 2. From here you can just go straight to multiply in that bracket, but I prefer making sure that my brackets are in the simplest form before I can then do anything that has to do with multiplying. So meaning, firstly, I will say this is the same as 6p squared plus 11p plus 4, and then I can multiply by the binomial, right? If I do that, it will give me 18p cubed, and it will give me plus 33p plus the 12p, but the 33 must be p squared. And then negative 2 will be minus 12p squared, and then negative 2, and that will be negative 22p, and then lastly it will be negative 8. You look at your like terms, firstly 18 is alone, and then the squared, and the squared is 33 and 12, so that will give me 21. So that will be plus 21p squared, and then the 12p and the 22 there will give me negative 10p minus 8. Let me just quickly verify for you everything here. 33 minus the 12 definitely will be 21, and that's what I will then have as my final answer there. And there is really nothing you can do here. Please don't add or subtract things that are not like terms, because then you're going to get it wrong. Lastly, everything that we've looked at so far, if you are simplifying an algebraic expression, always make sure that you expand whenever terms are in brackets. So expansion always goes with having brackets, and then always collect like terms as you've been seeing me do, and give your answers in the simplest form. Meaning simplest form, you can't just leave your answers as maybe in brackets something, and then in another bracket something, and then you just leave it like that. No, there must not be brackets if you are simplifying algebraic expressions. Then lastly, always look for patterns when trying to expand. What do I mean by patterns? Patterns is, are the exponents decreasing or are the exponents increasing? What does that mean? With every trinomial that you're going to get, the exponents will be decreasing, right? So an example is maybe x squared minus x minus 2. This is a trinomial. You can see my exponent is 2 there, my exponent is 1 there, my exponent here is 0. That's why there is really nothing there. And this becomes the answer. So that's the pattern that I'm talking about when I say always try to look at the pattern. Just to summarize everything in terms of our mapping, remember we looked at the big idea, which was multiplication, and it had to do with factors and the two properties that are very important for you to note under multiplication. You're expanding, the different types of expansion, monomial, binomial, and a trinomial. Remember that the prefix is what tells you how many terms you have, right? Mono 1, bi 2, tri 3. And that's what you then need to do. Guys, I really hope you enjoyed yourself as much as I did. I hope you made some notes that are important for you and you've taken down those steps that we followed throughout this. From me to you, the Maths Doctor, mathematics is food for the soul. Until next time.